Hello and welcome. In this video, we are going to take another look at Matlab vectors or Matlab one-dimensional arrays, and specifically we are going to focus in on the numeric vectors and specifically those of the double data type. Now, this video assumes that you have been watching some of the earlier videos and been following along, and it also assumes that you've watched the one specifically focused on how to create and access a vector or one-dimensional array manually. In this video, I'm going to show you how you can use the colon operator to create a sequence of values and then ultimately store them in a one-dimensional array or vector. And so to begin with, we're going to continue this pattern of poorly named variables. I'm just going to start off with the letter A. And what I'm going to do is I'm going to attempt to create a vector of values starting at 1 and going up to 10. Now, as a quick refresher, the last time around, we simply created them manually. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And I think you can quickly agree this is an absolutely terrible way of going about doing that. And occasionally you will be faced with the potential of having to do this, particularly when they are not a sequence of values and maybe it's just a one-time operation. So in this case, though, we do have a sequence of values and they start with 1 and go to 10. And even though they are integers, they will be stored as doubles. You can see here by simply highlighting and running it that now have a 1 by 10 double vector of values. Now, what we'd like to do is we'd like to use the colon notation to essentially reproduce this exact same process. And so what we'll do is we'll specify the start value for our vector. So in this case, it's going to be 1. We want to specify the increment, which is also going to be 1, and we're going to specify the maximum value. So in this case, the pattern is going to be the min, the increment, and the end, or rather the start, if you would, the increment, and the end. And so to see that we've effectively created the exact same vector, we'll simply just highlight this and run it. And again, you can see here I'm intentionally leaving off the semicolons so that down here in the command window, we can actually see the results of our Matlab code. And sure enough, in both cases, we have a 1 by 10 vector of values. The good news is, though, we are not just simply limited to this approach. We can also specify values other than 1. So we can do 1 colon 2 colon 10, which will start at 1, increment by 2, and end at 10. And in this particular case, you can see that I get the odd values between 1 and 10, stopping at 9, for a total of 5 values. So why don't we, as we're going along here, let's take just a second to document this. This is going to be a 1 by 10. This is also going to be a 1 by 10. And then ultimately, this one right here is going to be a 1 by 5. Now, if you recall from the earlier video, we can always transpose these into column vectors by simply using a single quote mark, in which case then what we end up with here is then going to be a 5 by 1 column vector. Now, we aren't done yet. As a matter of fact, we can continue this not only with integer values, which, although they are effectively stored as doubles, can be used for counting. We can also use non-integer values. In other words, let's say, for instance, that you would like to go from 0 to pi in some sort of fractional increments of pi. So in this particular case, we're going to start off with 0. We're going to go from 0. We're going to increment by pi over 4, and we're going to continue all the way up to 2 pi. Now, in an earlier video, I used pi, but I did not use the parentheses. As you will notice here with Matlab, with some of the functions, we have the ability to specify the parentheses or choose not to specify the parentheses. Pi is a great example of that. And so you can do it both ways, as you see down here in the command window. But fundamentally here, what I'm doing is I'm creating a vector, then going from 0 to 2 pi in increments of pi over 4. And again, what we're going to do is we're going to run this, and you'll see that in this particular case, I am now getting a 1/9 vector of values. And you can see down there in the console that I have fractional values of pi. Now, so far, you'll notice that I have conveniently been ignoring negative values, and there was really no reason to be ignoring them because we can, in fact, do the same with negative values. And so, for instance, if I want to start off at -10 and I want to increment by 1 all the way up to 0, well, sure enough, I will. And if you aren't counting along with me, you'll probably be surprised to notice that this is going to be a 1/11 vector, again, of doubles, regardless of whether it's positive or negative integers, they will all be stored as doubles. Now, we can also have a negative increment. So, for instance, we can actually start off, for instance, with the value of 10. We can increment by -1 and count down to 0. In which case, then we're just going to get a countdown vector that will go from the value of 10 down to 0. Again, notice here that we actually have 11 values because unlike the first example where I started at 1, I am stopping at 0 for both my F and my G vector. Now, let's use this last G vector to access some of the elements in our vector. And so you'll come up here, you'll see real quick that we do have a 1/11 vector that starts off at 10, goes all the way down to 0. And so what we'd like to do is we'd like to play around with accessing individual elements in that vector. Now, from an earlier video, you know that I can access singular values by just simply specifying the index. This will get us that first value, which was a value of 10. This will get us the second value, which was the value of 9. And then so on, all the way down to the 11th value. And again, I happen to know that there's 11 values in this vector. We'll see how we can automate this process in just a second. But ultimately, you need to know how many elements are in your vector to be able to access all of the elements in the vector. Now, we do have a couple of shortcuts to do this. And to start off with, the first one that I would like to introduce is the ability to get just the last element in a vector by specifying the end. And so regardless of what the size of the vector is, you can simply specify that you want to get the end value, which in this case is going to be 0. Another little thing that we can also do is we can specify multiple values in a vector to retrieve. So in other words, let's say, for instance, I want to get the first 2 values out of the vector. Well, if you can guess, you could probably take the first value out of the vector and the second value out of the vector independently and concatenate them into a new vector. And the way that we would do this is we would just simply specify the first value, and then the second value, and then we would put square brackets around it. In this particular case, we will assign it to the variable h. Now, this gets to be a little cumbersome, but it does work. However, I'd like to show you an alternate way of going about doing this in Matlab. Hopefully this first way makes sense, and the second way will probably just make a little more sense to you by specifying that you want to have every value starting at 1, incrementing by 1, and then ending at 2. Now, why does this work? Well, if you recall, when we first started with the colon notation, this syntax will use the pattern of start, increment, and end, just like we created the vector itself. And so what this will essentially expand out to is going to be G1, 2. In other words, it's going to pass these 2 values to G. In other words, it's going to call or request those 2 values from the G vector. And so in this case, you'll notice that I accomplished the exact same thing as I did on line 22. And in this case, the only thing we need to do is have our square brackets around here. This is why I like to get into the habit of using square brackets, because sometimes the Matlab syntax is not consistent. This is a great example of that. Likewise, you can also include the square brackets up here. In that first example, it didn't matter. But in both of these examples, you notice that I'm pulling the first and second value out of the original G vector. Now, let's take this just a little further here. Let's say that we want to grab all of the first half of the vector, or let's say the first 5 values out of the vector. Well, we simply specify the start, the increment, and the last value that we wish to get. In other words, this is going to pull the first 5 values. And sure enough, you could see that I'm getting 10, 9, 8, 7, and 6. Well, we don't have to stop there, because if you recall, we can also leverage the end. So what if I'd like to get the last 6 values? Well, that's pretty easy. We can just simply specify that we wish to start at the 6th value, we want to increment by 1. And, well, we could either type in 11, which would technically work, or what we can do is, if we aren't sure what that last index is going to be, we simply do the exact same thing, except we replace that 11, that hard-coded 11, with end. And in both cases, what you see here is that I get the last 6 values from the vector. So these are the last 6 values. And I think you can guess that I can combine these two approaches now to be able to get select elements out of the vector. So let me give you an example here. What if I asked for every odd indexed element? So in other words, we're going to make a quick note here that I want to get every odd indexed element. Well, the first thing we want to do is recognize, how would we create the odd indexes or the odd indices? And if you recall from the earlier example, we figured that out accidentally, right? We started with 1, we incremented by 2, and then in this case, we know that we have 11 elements to work with. And so this would create then a vector that starts at 1, goes up to 11 in increments of 2. Well, we can accomplish the same thing by simply passing this vector of, ultimately a vector of indices, to our G vector, and ultimately we are going to grab only the odd indexed values. Again, I'm going to skip over the letter I. I'm going to go to J, and I'm going to look then for the values starting at 1, incrementing by 2, and then ultimately we can specify either 11 or we can specify our end. And in this case, you'll see that I'm getting only the odd indexed elements. And just to confirm on this one, if you'll take a look over here in our variable editor window, we'll see that the first value is 10, the third value is 8, fifth value is 6, and so on. And that looks pretty confidence-inspiring, especially when you get down here to the 11th value, and you'll notice that it is, in fact, 0. Now, the last trick that I want to show you is, let's say that you wish to reverse the contents of the vector. In other words, basically, we want the first value to be the last value. We want the second value to be the next to the last value, and so on. And we could, of course, do this manually, and then that would be rather painful. But instead, what we're going to do is we're going to, again, leverage one of the tricks that we saw earlier, and that allows us to count down from 11 by increment of -1 down to our value of 1. And this, again, this is for our indices here. And if you recall, then basically we're going to get values from 11 all the way down to 1, but counting down. And again, what we'd like to do is we'd simply like to pass that to our G vector. So in this case, what we're going to do is we're again going to leverage a new variable, K. K is going to be equal to the vector G, and we are going to reverse the order of the elements. So 11, counting backwards by -1, counting down to 1. And yes, just like you guessed earlier, we can substitute in our end for our 11. And sure enough, then what'll happen is it'll count the values or create the indexes from 11 down to 1 by increments of -1, and then it'll pass that to the G vector. And if you look at the original G vector, again, remember that it started off at 10 and it counted down to 0. Well, the new K vector simply reverses the entire order. Now we can spend the rest of this video coming up with all sorts of cool combinations. As a matter of fact, we'll see when we start getting into arrays that there's even more possibilities. I do, however, want to leave you with one last possibility. And let's say that you accidentally make a mistake with your indexing or with creating your vector using the colon notation. Well, the good news is there's not really going to be the errors. You're just not going to get any valid values. And to understand what I'm talking about here, I'm going to create one last vector here. We'll call it L. We are going to, again, use the square brackets and the colon notation. I'm going to start off at 1, but for some silly reason, I'm going to use an increment of -1, and I'm going to try to count to 10. And I think you can guess you can't get from 1 to 10 by counting backwards. And sure enough, if you were to highlight and run this, you'll see that you get an empty double row vector, double again being the data type. And in this case, it's a row vector because it is a 1 by n, in this case, a 1 by 0. So the good news is there's not a lot that can go wrong here as long as you're paying attention to the increment as it relates to the start and end. There are some shorthand notations, particularly you'll discover that you actually don't have to specify the increment when the incremental value is 1. However, I would discourage you, especially in the beginning, from using that syntax because it can lead to some confusion. There are also some faster ways to go about doing this using solely this colon. And again, we'll get an opportunity in later videos to be able to see how this works. I would focus simply on the ability to create these vectors using the start, increment, and end, and also always encourage you to go ahead and use the square brackets, even if Matlab suggests that it is unnecessary. So as always, hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me, and thank you for watching.